Hello, my name is Rich Howard, owner of Architectural Builder Supply, and this video is to show you what a normally open circuit would be using the GRI. Forgive me. This is their part number 184-12-W, a recessed magnetic contact in a white finish. So the contact that we have here a door contact. This is a normally open electrical configuration, normally open. That means when you take it out of the package, is the way it's really defined, the circuit is open using this equipment when you take it out of the package. When you bring the two parts together, it will close the circuit. But when it is allowed to resume its natural state, the two pieces separated from each other, the circuit will be open or discontinuous or broke or not closed to where electric current can flow through. So a normally open circuit means in its normal state, its common base state, electricity will not flow through the circuit. So to demonstrate that, I have a power supply putting out 8 volts AC. I have an annunciator, just a buzzer, that will take 8, that will work at 6 to 8 volts AC. I have my contact wired, as you can see here on the desk, right here. So I've got the power coming in to to what will be the switch. The switch is normal; it's now normally open because that's its standard state. I have the other end of the wire continuing on so that I can go to the load. This is the load. Then from the other terminal of the load, I'll go back to the power supply. So off the power supply, I've got a black and a white wire. The black wire comes through and goes to my switch. That circuit continues through this wire back to the load. I then have to connect the load back to the power supply. It's just simply what it is. I could take these two wires and run it right to the terminals on the annunciator, but then that means it'll run all the time. It'll just always buzz. But when I take one of those legs and I cut it, and I insert the switch into that run, which I've done here, and here, okay, and then to the annunciator, then back to the power supply, it all works just fine. So I'm going to, the power supply is plugged in. I'm going to take what I know to be my leads, my leads, and go to the annunciator, and nothing's going to happen because there's no current flowing to the annunciator because this contact is normally open. Okay, I'm going to put those down. Now I'm going to bring my contact, the magnet part, in proximity to the switch. That'll work. Now I'm going to touch my leads back down. This is closed now. This is now closed. Those two contacts are pushed together, as you can see. So when I touch my leads, it should buzz. As soon as I pull that off, put that over here, touch my leads again, nothing's going to buzz. Bring my contact back, so it's closed. Okay, works just fine. So what would be the application of this? The application would be, and the first thing I want to do is simply remove the incoming power. The application would be where you have a, so in this switch application, let's back up a little bit. In this switch application, we are going to have, when the door is in the closed position, the two contacts will be together when the door is in the closed position. When that door opens, the contact is going to be broken, or the circuit will be open because the natural state of this is open. That means that somewhere upstream, circuit's going to be cut to something. What it's cut to, who knows? A simple example very likely is going to be to a relay. And a relay is going to, once that circuit is open, the relay itself will be powered, but as soon as that circuit is open, something will happen on the relay to trigger something else. You could have something as simple as a desk. You know, I always think of an airport and the doors that are on the jetway. I would think, and I'm not an expert on the matter, but I would think that someone is monitoring those doors on the jetway. There could be something as simple as a control desk, a central station where someone is sitting there, and that you have, red lights or green lights on everything. Okay, that means the doors are closed, whatever you want to call it. Green lights everywhere on all of the doors on the jetway. When one of these circuits are open, a relay might trigger, causing one of those lights to go from green to red. That's a pretty simple scenario. You could also have, rather than two lights, you could have that annunciator, where you could have a buzzing if that circuit is opened, meaning if the door is opened. You could also simply do the same sort of switch, but in a normally closed configuration, so that when the door is closed, power is flowing through there, and you could have power flowing through that, so that you are arming, some sort of a indicator. Again, same scenario, just in the reverse orientation. Power is closed, running through there, so that you have an electromagnetic lock, let's say, that is energized until the button is depressed to exit, or the sensor senses detection in the detection zone. That circuit is temporarily opened. You can exit because the power drops out to the maglock. While the door is open, that circuit is temporarily open. So there's no power going back to the maglock until the door closes. Resuming its normally closed state, power flows again. So power is cut to the magnet while the door is in the open condition. That could be, I'm not an expert when it comes to the different, several and many different variations of what could occur with typical electrical circuits, but those would be examples of how that would work. And the bottom line is, when you have a switch, this is just a switch. Just think of your light switch, on or off, on or off, on or off. It's the same concept, at least it is to me. You're going to have in your electrical circuit 4 components, and it's helpful to know the 4 components because it's helpful to remember what it is you're doing when you're wiring something. And you have the power. The power was my Trine 5205 plug-in transformer. You have the conductor, and that's the 2 bundles of wires, very low gauge wires that I should have been using something heavier, but only these are literally cables for card readers. But it was so temporary, I knew that I wasn't going to heat anything up based on the voltage running through, but more so the amperage. Obviously the amperage at 8 volts. Probably should have used a thicker wire. This is 1250 milliamps, so 1.25 amp is what this was capable of. The amp draw of my annunciator is really the important part. My power supply can produce it. The box for the buzzer or the annunciator doesn't tell me amps. We could obviously search that and know what it is, find out what the amperage, but let's just assume it's quite small. So you have the conductor. So switch, my wires were the conductor. Your load, well, that's the annunciator, okay? And then the other component, of course, is going to be your power. So we've got power, switch, load, conductor. Those are the 4 components. In that electrical circuit, you need to tell it how to behave, in the sense that, is there power running continuously or is there not? And that will give you the basic understanding of what's happening at a circuit. Then another level beyond that would be adding a relay, where you can, when that relay would be powered, you can switch that behavior. So if your switch does closed or open, the relay can also then act in the opposite fashion, open or closed, open or closed, open or closed, to affect different changes, is the bottom line. And you can also use a low amperage rated, contact or switch like this to be able to power something much greater to happen with slightly more exotic pieces of electrical equipment. Anyway, that's the long way around showing the difference between a normally open and a normally open switch and what a normally closed switch would be. Any questions on that, please feel free to reach out to us. My name is Rich Howard, owner of Architectural Builder Supply. Thank you. If you've enjoyed this video, please click thumbs up. Please click subscribe as well, and even share the video with someone that you know. And if you have any questions for a future video, please send them our way and we will make every attempt to oblige. And thank you very much.